Alright, so in this video, this is NTI day 19, we're going to be doing example 1 and example 2. And then guys, after this, you will know how to do exercise 1 and exercise 2 because they're solved the exact same way. I think that you can make some sense of this, so I'm not too worried about this being terribly difficult. So if you remember in the notes section, we know that the radius and the tangent line of the same circle will form a 90-degree right angle at the point of tangency. And the point of tangency, again, is where that single point where the tangent line intersects the circle. So we're going to use that bit of knowledge for example 1 and then also example 2. So the whole lesson, guys, is about the fact that the radius of a circle forms a right angle with the tangent line. That's what this whole lesson is all about. So we need to dig back in our memory and try to remember properties of right angles. So example 1, OC is the radius. Okay, so O is the center of the circle, and again, guys, it's not perfect. I know it's kind of. I mean, that's super flat up there. So this is not a good circle. But I did not bring my compasses from school. OC is the radius. So my question is line AC. So this line here is AC. Is AC a tangent line? Is AC tangent to the circle? Well, how do we know if AC is tangent? So something that some of you like to do is you like to just look at it and be like, oh, yeah, that looks like it's a tangent line. So I'm gonna. This is not drawn to scale. So they're all going to look like tangent lines, but sometimes they might not be. How do we know for sure if it's a tangent line? Well, we know that tangent lines form right angles at the point of tangency with the radius, which means the radius right here needs to form a right angle with this tangent line, and a right angle is 90 degrees. So is this angle C, is the measure of angle C equal to 90 degrees? If it is, then it's a tangent line by definition. If it's not, then it's not a tangent line. So how do we know if this is 90 degrees? Well, does 90 plus 32 plus 58 add up to 180 degrees? Because if you remember a triangle, all the angles inside of a triangle add up to equal 180. So that means angle A plus angle B plus angle C needs to equal 180 degrees because it's a triangle. That's not B, sorry, I've been saying B. I guess that's O. Yeah, that's O, not B. There's no B in here. A is 32 degrees. O is 58 degrees. We don't know what C is, and that's 180. So the way to find an unknown angle, if you have the other two, is just going to be your total, which is 180, and then you're just going to shave away what you know to get what you don't have yet. So 180 minus 32 minus 58. Plug that in your calculator. You will find that 180 minus 32 minus 58 is equal to 90 degrees. And that means the measure of angle C is equal to 90 degrees. So 180 minus 32 minus 58 gives me what I'm left over with, which is 90. So if angle C is 90 degrees, then yeah, AC is a tangent line. So now we're gonna move on to example 2. Guys, it's the same sort of concept. Is we're trying to show that this is 90 degrees. If we can prove that this is 90 degrees, then we have proven that this is a tangent line. Is line AC tangent to the circle? So we don't know. We don't have angle measures. Like we don't know what that angle is. We don't know what this angle is, and we don't know what that angle is. we know it has to be 90 if it's going to be a tangent, but we don't know if it's 90 yet. So how are we going to do this? The trick for this one, if you don't have angles, then you're not going to you're not going to need angles, degrees in this type of problem, because you have sides. And if you remember from the notes, I mentioned the Pythagorean theorem. Well, that's going to come into play here. Pythagorean theorem says a squared plus b squared. So Pythagorean theorem says a squared plus b squared equals c squared, where a and b are my base and my height of my triangle, and then c is my hypotenuse. So here's my hypotenuse. The hypotenuse is the longest side of a right triangle. So we're going to use Pythagorean's theorem with all these sides just to see if it works. So we've got a 3, a 4, and a 5. So the tangent line, or what we're trying to determine if it's the tangent, that can be our A, the radius can be our B, and then this part right here, this hypotenuse, can be C. So we'll just do, well, let's test it. We'll do 3 squared plus 4 squared equals 5 squared. So basically all we're doing, if this is true, if this holds true, then we're proving that AC is a tangent line. Because again, Pythagorean theorem only works for right triangles, and a right triangle is a triangle that has a 90-degree angle right there. So if Pythagorean's theorem works, that means this is 90 degrees. That means that 90 degrees with the radius and the point of tangency, or the tangent line. So 3 squared is 9, plus 4 squared is 16, is equal to 5 squared, which is 25. So is that true? Is 9 plus 16 25? Yes, 9 plus 16 is 25. So we determined that AC is tangent. What if, so that's the end of the notes. Let me just really quick, what if this was a 6? Instead of a 5, what if I said this is a 3, that's a 4, and that's a 6? Is this a tangent line? Well, we're going to do that same thing we just did. We're going to do 3 squared plus 4 squared is equal to 6 squared, and we're just going to see if this matches that. So 3 squared plus 4 squared, that's 9 plus 16. So we know 9 plus 16 is 25. So is 25 equal to 6 squared, which is 36? No, 25 is not equal to 36. So if this were 3, 4, and 6, then this would not be a tangent line because the Pythagorean's theorem didn't work. However, the question originally was 3, 4, and I'm going to put this 5 back in here. And then we did this work over here. 3 squared plus 4 squared equals 5 squared. 9 plus 16 equals 25. Since 25 equals 25, that checked out. So in the example, the answer is yes. But then I just did, I just scratched that out and I said, what if that was a 6? What if that was a 6 instead of a 5? And I showed you where we can prove that that was not a tangent line. So know how to do these, guys. If you can follow along with the examples, you can do the exercises.